Hey guys, this is Carrie, and this is lesson 2 from Unit 11. Alright, so let's get started. Our do now is a quick review of what we did last time, so if you haven't done it yet, please pause the video and take a look at these problems, and then come back when you're done. Okay, so let's go over our do now problems. Using the information in the diagram below of triangle MYI, determine the value of x. Round your answer to the nearest tenth. So last week, or no, not last week, oh my gosh, yesterday, we learned about three formulas that relate the angles and sides of a right triangle. And those formulas could be easily remembered using the mnemonic SO, CA, TOA. And the idea here is that we need to make sure that we're using the correct formula for the situation that we were given. So in this situation, we have our focus angle right here. And once we identify our focus angle, that allows us to label all the sides using their vocabulary. So across from the right angle is always the hypotenuse. Opposite from the angle that we're focusing on is always the opposite. And finally, if you've done them in this order, hypotenuse, opposite, the last remaining side will be the adjacent. And usually that's the hardest to identify right off the bat. Okay, so looking at what we've got here, we've got our angle, we've got our adjacent, we've got our hypotenuse, and we don't have the opposite, so we're going to cross that one out. So we're going to avoid all of the formulas that have an O for opposite. So cosine looks like it's the one that we want to use, because that uses adjacent and hypotenuse. So let's set our formula up. The cosine formula will be cosine of the angle is 39 degrees this time, equals adjacent, that's what the A is for here, which is x divided by 10.7, which is the hypotenuse. Lastly, we just need to solve for x. So cosine of 39 degrees, that's just a number that we can compute with our calculator. To find that number, let's go to Desmos. So if you're loading Desmos up for the first time, make sure that you change from radian mode, which is the one that it usually has, to degree mode, because we're measuring our angles in degrees. And so let me just look back at the problem. It's cosine of 39 degrees. So we go functions cosine 39. So that's 0.7771 equals x divided by 10.7. And we're one step away from solving for x. So we multiply by 10.7 on both sides. That leaves us with x equals 10.7 times 0.7771, 8.31. Now it's really important, it says to round to the nearest tenth here, so if we write 8.31, we're going to actually lose a point on our region, so it should be x equals 8.3, because tenths place is just one decimal place. Now finally, we want to check to make sure that that makes sense. Yes, it does, because this is shorter than the hypotenuse, and we know the hypotenuse is the longest side. Alright, for problem 2, using the information in the diagram below of triangle PQO, determine the measure of angle P. Okay, so this time it's the angle that's unknown, but that changes nothing so far. We're still going to set it up using one of the three formulas, and we can remember those formulas by doing SO, CA, TOA. And I like to write it like this because it shows the fractions, in case you were unsure why I write it like that. But here we go. Let's see if we can set this one up. So once we identify our focus acute angle, we can label our sides. Across from the right angle is the hypotenuse. Opposite from our focus angle is the opposite. And the last remaining side is the adjacent. So this time we want a formula that involves the opposite and adjacent. And we're going to cross out the hypotenuse because we don't know anything about that one. So we're going to cross out these two because they both use the hypotenuse. And so we're left with tangent. And that does use opposite and adjacent, so it seems like we're in pretty good shape. So before you worry about any inverse operations and things like that, make sure you write your starting equation. So the equation is always tangent of the angle. And this time we use that new symbol for our angle, theta. And this is kind of like x for angles, but whenever we don't know an angle, we're always going to call it theta. This is a Greek letter. Okay, so tangent of our angle is equal to opposite over adjacent, so 9.2 divided by 6.7. Now we're one step away from solving for theta. The thing that we need to invert here, that we need to get rid of, is the tangent. So to get rid of tangent, the opposite operation, the inverse operation, is called tangent inverse. And that's a -1 up there. And so we do tangent inverse to both sides. Tangent inverse and tangent cancel out, giving us theta equals tangent inverse of 9.2 divided by 6.7. And this is all just operations and numbers, so we can use our calculator to evaluate that. So tangent inverse, we go into our functions. It's in trig in case you're not on that menu. Tangent inverse of 9.2, I think, divided by 6.7. Let's see if we got that right. Yep, we did. Okay, and the final answer is 53.94. And when I said final answer there, I'm not correct. We have to round it to the nearest whole degree. That means a whole number. So theta is equal to 54 degrees. And that seems like a reasonable amount for this angle. It's less than 90 degrees, so we like it. Alright guys, so the good news is we've been having this challenge with our calculators where we don't necessarily have them. And so this lesson is all about trig without a calculator. So let's see how we do these problems with no calculator. So trig without a calculator is kind of similar to square roots. So pause for a second. Or pause the video for a second after we're done saying this. Please do problem number 1 on your own. So hopefully, as you paused and you did that, you realized that you actually are pretty good at square roots without a calculator. In fact, the square root of 16 is 4, and that's because 4 times 4 equals 16. The square root of -4, first it seems kind of impossible. We're wondering what number times itself gives us -4. Well, 2 times 2 is 4. But then we remember back to Unit 5, and we think, okay, well, if we want to do the square root of -4, that's the square root of 4 times -1. And the square root of 4, that's definitely 2. And the square root of -1, that's definitely I. So we get 2i when we do that. So this should be 2i times 2i equals -4. Notice that we didn't need a calculator for these two. We are kind of good to go with no calculator. However, for problem C, there's actually no way that you would do that without using a calculator. You'd have to use a calculator. And the reason why is this one's not a perfect square. So it turns out that trig work kind of the same way. There's many trig problems that we can do without a calculator. But similar to these square roots, there are some nasty ones that we do need a calculator for. So if you look at problem 2 here, this is going to illustrate which of the trig functions we can find with no calculator. So without using a calculator, you're able to do it for 30 degrees, 60 degrees, and 45 degrees. But if you encounter any other angle measure, sine of like 47 degrees, you're probably going to need a calculator. And we're going to see in a future lesson how we can extend these well-known ones to being able to find some other ones. So first off, you guys have no idea how to do this. And so we're going to skip problem 2, and we're going to look at 2 essential diagrams, and then we're going to come back and we're going to do these. So these 2 essential diagrams, they're given to you on the SATs. They're not given to you on the regions. And you've got to be able to draw these for the regions. So in order to find the sine and cosine for 30 and 60, you can actually build a triangle that has a 30-degree angle, a 60-degree angle, and a 90-degree angle. And you know that that's going to work because together those add up to 180. So we call this the 30, 60, 90 triangle. And so for a 30, 60, 90 triangle, I always draw it the same way. I draw the 90-degree angle here, the 30-degree angle here, and the 60-degree angle here. Now, it turns out that the sides are always in the same proportion for a 30, 60, 90 triangle. It's always going to be 1 across from the 30, 2 as the hypotenuse, and square root of 3 for the remaining side. And so if you can remember that there's always a 1 across from the 30, the hypotenuse is always 2. It's kind of like 1, 2, 3, but it's 1, 2, square root of 3, a little bit funky. All right, so this triangle is really important to remember because it actually gives you all of these trig ratios for free without a calculator. And this is so important for calculus because AP Calculus, the majority of the tests, you can't have a calculator. It's also just important for being able to do math on the fly and help us understand things. So let's see how we use it. If we want to find the sine of 30 degrees, then we're focused in on 30 degrees. And so we have to do, remembering so, ka, toa, sine is going to be opposite over hypotenuse. So that would be 1/2 for this one, because we're focused in on 30 degrees. Cosine is adjacent over hypotenuse, so that's going to be square root of 3 over 2, because 30 degrees is our focus angle. And tangent is opposite over adjacent, so that's going to be 1 over square root of 3. So now, of course, everything is going to change when we switch our focus to 60 degrees. So if you switch your focus to 60 degrees, see if you can fill in these three on your own. Take 1 minute to do that now, and then come back to the video. So pause it and come back. Okay guys, so hopefully you paused it. Sine is still opposite over hypotenuse, but in this case, because we're focused on 60 degrees, opposite is square root of 3 over hypotenuse is 2. So we get square root of 3 over 2. And this is going to be pretty remarkable because we just found out that the sine of 60 degrees is this number. And so that makes it super easy, no calculator required. The cosine of 60 degrees, well, that's adjacent over hypotenuse. That's going to be 1 over 2. Tangent of 60 degrees, we don't need a calculator to find it. That's always going to be equal to opposite over adjacent. So square root of 3 over 1, or just square root of 3 if we want to write it simply. Now, this triangle gives us 30, 60, 90. But 45 turns out to be a pretty well-known angle as well. So if you think about putting a 45-degree angle in a triangle, if one of them's 45, we know it has to be a right triangle, so one of them's 90. Let's see, what does the third one have to be? Well, we know they add to 180, so we do 45 plus 90, that's 135. We know together they're 180, so we do 180 minus 135. And that gives us 45 degrees. So this last essential diagram is called a 45, 45, 90 right triangle, because both angles are actually 45 degrees in it. And if you check it, that does add to 180, so we're good to go. All right, so here we go. The sides for this one are even easier to remember. Just like before, opposite from here, we put a 1. Because the two angles are congruent, we know the two sides are congruent, so that's also 1. And then here, 1 and 1 makes the hypotenuse. If you do the Pythagorean theorem here, it makes it square root of 2. But we're not showing our work for that because I think it's clearer just to present it like this. So, this question that students always have when they do the final row here is, which of the 45-degree angles do we use? And it turns out you can use either one because opposite is always 1, regardless of which one you're focused on. And adjacent is always 1, regardless of which one you're focused on. So I always choose this one in the bottom left because it's coolest to me. So sine is opposite over hypotenuse, 1 over root 2. Cosine is adjacent over hypotenuse, so 1 over root 2. Tangent is opposite over adjacent, so 1 over 1, which is just 1. All right, so you're probably wondering, how do you use these to actually solve for angles or sides in other problems? Well, here's how we do it. Remember, there's no calculator allowed here. All right, so without using a calculator, solve for x. If necessary, make sure that your answer is in simplest radical form, and that, if necessary, your answer is a fully reduced fraction. Okay, so we want to set up our trig problem. So we've got our focus angle here. We label the sides. This is the opposite. This is the hypotenuse. This is the adjacent. We don't want the adjacent anymore. So we think so, ka, toa. Now, we didn't want the adjacent, so we've got to cross out anything that has an a in it. And we're left with sine. And sine is pretty good because we have information about the opposite and hypotenuse. So we write our formula. Sine of our focus angle, 30 degrees, is equal to opposite divided by hypotenuse. Now, no calculator allowed. So how do we do this? Well, it turns out sine of 30 degrees, we actually know that one. If we go back to our reference triangle, it got a little bit crowded, so I'm just going to redraw it here. Usually I redraw these each time I need them. We're going to use our 30, 60, 90 triangle as a reference. So it's kind of like your reference sheet in science class. but you don't get it provided for you. You have to remember it. So here we go. We've got our 30, 60, 90 triangle. So this will be 30 in the bottom left always, 60 in the top. And then 1 is across from the 30, 2 is the hypotenuse, and then 1, 2, square root of 3 instead of 3. All right, so here we go. If we want sine of 30, we're going to focus in our reference triangle on the 30-degree angle. Now opposite from that is 1, and the hypotenuse is 2. So we're given from our reference triangle that the sine of 30 degrees is 1 over 2. And that equals 8 over x. So what's important to remember is there's actually two different triangles here. There's the triangle from the problem in green, and then in blue over here, we drew a reference triangle so that we could figure out the sine of 30 degrees. And this is an unusual idea, but it's important to keep track of. Notice that we didn't use a calculator at all. So now, to solve for x here, we multiply by x on both sides. That will cancel division by x. That gives us 1/2 x equals 8. We multiply by 2 to cancel the division by 2. That gives us 1x, which is just x, equals 16. And so with no calculator, we've managed to solve for x. And 16 makes a lot of sense, because that's supposed to be the longest side, and it is longer than 8. Let's see one more example of this in action. Without using your calculator, solve for x. Same instructions as last time. All right, this time we've got our focus angle, 45 degrees. We label our sides, opposite, hypotenuse, and adjacent. So we want the adjacent and the hypotenuse. So we go so, ka, toa. Now because we wanted the hypotenuse and adjacent, we want to avoid the opposite, because there's no information about that. So we're going to cross out all the formulas that have an opposite in it, and we're going to go with cosine. So the formula for cosine is cosine of the angle, 45 degrees, is equal to adjacent, which is x, divided by hypotenuse, which is 26. So now you would immediately reach for your calculator usually to find the cosine of 45 degrees. But it turns out you don't need it. This is one of our reference angles. So we're really good with 45. In fact, we have a triangle called the 45, 45, 90 triangle. And it's a different triangle than this one here, but we draw it here. So we put our 45 degree angle here, 45 degree angle up top, 90 degree angle. And because this is two congruent angles, we know both of these sides are 1, and we know that this side is the square root of 2. So for cosine of 45 degrees, well, we can pick either one, so I'll pick this one. That would make this the opposite, this the adjacent, and this the hypotenuse. So cosine is adjacent over hypotenuse. So cosine of 45 is 1 over root 2 equals x over 26. So this is from the reference triangle. And then this side is just the same as what it was before. Now to solve for x here, we got to do a little bit of fancy work with these fractions. We're going to multiply by 26 on both sides. These cancel out. That gives us 26 over 1, because that's the same thing as 26. So you get 26 over 1 root 2, which is just root 2, equals x. And actually, we're done. So we have x. We can't actually get it to a non-fraction because we don't have access to our calculator, but we were able to solve for x. We got x by itself. And that answer might not be as satisfying as like a single number answer, but it's got to be pretty satisfying that we just did a trig problem with no calculator. So at this point, guys, you've got some important stuff, neat stuff, and tough stuff to do. So just to review the expectations here, guys, please redraw the essential diagrams. That is checkpoint 1, so I'm going to be looking for that with the photos that you send in. For checkpoint 2, you should not be using a calculator for any problem after this. So without using a calculator, maybe these triangles will be helpful. See if you can do the rest of the problems. So there are 4 checkpoints. And just to be clear, the neat stuff is optional, and the tough stuff is optional. However, I do recommend that you give the neat stuff at least a try, because I think you guys will be surprised at how quickly you're able to figure out the inverse trig functions here when you get to it. All right, so please make sure that you do all of the problems from the important stuff, including but not limited to the checkpoint problems, and make sure that you include the diagrams. When you're done, please send in a picture of your work so I can give you credit for your checkpoints. All right, guys, that was a great class, and I'll not really see you. I don't really know. I'll talk to you guys soon. Bye.